Hello everyone, in this video we are going to discuss about Lewis representation of simple molecules, the Lewis structure from the chapter 4 chemical bonding and molecular structure, class 11 chemistry. The Lewis dot structures provide a picture of bonding in molecules and ions in terms of the shared pairs of electrons and the octet rule. Writing the Lewis dot structures of molecules that is very useful to understand the formation and properties of a molecule to a large extent. There are a few steps to be followed to write the Lewis dot structure. See, the step 1 is determine the total number of valence electrons. That is, the total number of valence electrons required for writing the structures are obtained by adding the valence electrons of the combining atoms. For example, if you consider CH4 molecule, see, carbon has atomic number 6, so 2 for 4 valence electrons. One hydrogen atom has 1 valence electron, so 4 hydrogen atoms together will have 4 into 1 equals 4 valence electrons. So there will be 4 valence electrons from the carbon atom. There will be 4 valence electrons from the 4 hydrogen atoms. So total number of valence electrons will be 4 plus 4, which is equal to 8. See, for anions or negative ions, each negative charge would mean addition of 1 electron, and for cations, positive charged ions, each positive charge would result in subtraction of 1 electron from the total number of valence electrons. For anions, negatively charged ions, each negative charge would mean addition of 1 electron, and for cations, positively charged ions, each positive charge would result in subtraction of 1 electron from the total number of valence electrons. So let us see one example. See, let us consider one negative ion, which is CO3 2 minus ion. For CO3 2 minus ions, there are 2 negative charges here, which means the presence of 2 additional electrons than those provided by the neutral CO3 atom. Okay, for CO3 neutral CO3 molecule, you see there is one carbon atom, there are 3 oxygen atoms. For one carbon atom, its atomic number is 6, so valence electron will be, you see electronic configuration 2, 4, so number of valence electrons 4. Okay, for one oxygen atom, atomic number 8, so electronic configuration 2, 6, number of valence electrons 6. There are 3 oxygen atoms in CO3. So 3 oxygen atoms, so total number of valence electrons will be what? 4 from carbon, okay, 6 from 1 oxygen atom. So for 3 oxygen atoms, we will get from 3 oxygen atoms, we will get 18 valence electrons. So total 18 plus 4, which is 22. Okay, now when you consider, so for CO3, the total number of valence electrons, that is equal to 22. 4 from carbon, 6 from each oxygen atom. So from 3 oxygen atoms, 3 into 6 equal to 18. So total 22. Now for CO3 2 minus ion, the number of valence electrons will be what? CO3 2 minus ion, there are 2 negative charges, which means the presence of 2 additional electrons. Okay, than provided by the neutral atom. So neutral atom provides 22 valence electrons. So CO3 2 minus ion will provide 22 plus 2, 2 additional electrons. So this is equal to 24. Now, let us consider a cation, a positive ion, which is NH4 plus. See, NH4 plus ion, it has one positive charges here, which indicates the loss of 1 electron from the group of, neutral atoms. That is, when you consider the neutral form of this NH4 plus, that is simply NH4. There is one nitrogen atom, there are 4 hydrogen atoms. From nitrogen atom, we will have 5 valence electrons. From one hydrogen atom, we will have 1 valence electrons. So from 4 hydrogen atoms, we will have 4 into 1, which is equal to 4 valence electrons. So total number of valence electrons from NH4 neutral atom or neutral molecule, this will be what? 5 plus 4, which is equal to 9. Okay, so for NH4 plus, number of valence electrons will be equal to what? one positive ion is here, one positive charge is here. That means the subtraction of one electron from the total number of valence electrons. So total number of valence electrons for the neutral atom or neutral molecule is 9. So 1 should be subtracted from this, one positive charge, no, so 1 should be subtracted from this 9. So total number of valence electrons for NH4 plus will be equal to 8. Okay. So far we have been discussing about step 1. Now let us see the step 2. Step 2, draw the skeletal structure of the compound which could be known or guessed intelligently. That is, we just want to draw the skeletal structure of the compound. You see, we just want to place the central atom. Okay, then arrange all the surrounding atoms. In general, you see, when you consider NF3, there is one nitrogen atom, there are 3 fluorine atoms. So when we draw the skeletal structure of this compound NF3, we want to place the central atom, that is one atom would be at the center. Then we just want to arrange all other surrounding atoms. So in general, the least electronegative atom occupies the central position in the molecule or ion. In general, the least electronegative atom occupies the central position in the molecule or ion. For example, when you consider NF3, there are 2 atoms, one is nitrogen atom, another one is fluorine atoms. Among these 2, nitrogen and fluorine is the most electronegative atom and nitrogen is the least electronegative atom when you consider these 2 atoms only. Okay, so the least electronegative atom would be placed in the center. So nitrogen is the central atom. Fluorine occupies, the terminal positions. Okay, the surrounding atoms will be fluorine, nitrogen will be at the center. So this is the skeletal structure for NF3. Okay, similarly, when you consider this ion, CO3 2- ion, there are 2 atoms, one is carbon atom, another one is oxygen atom. When you compare these 2, carbon is the least electronegative atom and oxygen is the most electronegative atom when you compare these 2. Okay, so least electronegative atom would be placed at the center, that occupies the central position. So carbon will be placed at the center, then oxygen will be the surrounding atoms. Okay, so this is the skeletal structure for CO3 2- ion. Now, what about step 3? In step 3, we just want to distribute the electrons around the atoms and connect the atoms with bond to satisfy the octet rule. The bond can be the single bond, double bond or triple bond, which we have discussed in our previous video. See, in step 3, we just want to distribute the electrons around the atoms and connect the atoms with bond to satisfy the octet rule. The basic requirement is each bonded atom gets an octet of electrons. After accounting for the shared pair of electrons for single bonds, the remaining electron pairs are either utilized for multiple bonding or remain as the lone pairs. A lone pair, see what do you mean by a lone pair? A lone pair is a pair of electrons localized on a single atom and they do not participate in bonding. Lone pair, they are the pair of electrons, they are not shared with other atoms. So you see, let us consider one example for the Lewis representation of the molecule NF3 to get an idea about all the 3 steps. So, we are going to see the Lewis representation of NF3 using all the 3 steps which we have discussed now. So, to get the Lewis representation of NF3, there are 3 steps to be followed. Step 1, we just want to count the total number of valence electrons available for bonding. So, in NF3, you see there is one nitrogen atom. Okay, its atomic number is 7, so electronic configuration 2, 5. 5 valence electrons are there. If you consider one fluorine atom, atomic number 9, so electronic configuration 2, 7, 7 valence electrons are there. there are 3 fluorine atoms. Okay, so total number of valence electrons will be 5 plus 5 plus, that is 5 from nitrogen, 7 from 1 fluorine atom. So there are 3 fluorine atoms. So 3 into 7 from 3 fluorine atoms. So 5 plus 21, which is equal to 26. So number of valence electrons available for bonding, that is equal to 26. Okay, now step 2, we just want to draw the skeletal structure. So there are 2 atoms actually, basically nitrogen and fluorine. Nitrogen, when you compare nitrogen and fluorine, nitrogen is the least electronegative atom and fluorine is the most electronegative atom. So least electronegative atom would be placed in the center. Okay, then fluorine will be distributed in its surroundings. Now step 3, distribution of electrons. So you see nitrogen, its valence electron number is 5. So I am just distributing the electrons around nitrogen. Okay, these dots are actually representing the electrons. Now for fluorine, 7 electrons are there as valence electrons. Okay, so 2, 4, 6, 7. Okay, then 2, 4, 6, 7. Then 2, 4, 6, 7. Okay, that is actually sharing of electrons is actually taking place here. This fluorine will share its 1 electron with nitrogen and nitrogen will share its 1 electron with fluorine, like that. So actually what happens is, there will be a sharing of electrons between this nitrogen and fluorine. There will be a sharing of electrons between this nitrogen and fluorine. There will be a sharing of electrons between this nitrogen and fluorine. Alright. So you see, there is a pair of electrons shared between this nitrogen and fluorine. A pair of electrons shared between this nitrogen and fluorine. A pair of electrons shared between this nitrogen and fluorine. And you see nitrogen itself has, 8 electrons around it now. Now let us draw the bond. See here, one pair of electrons is shared between this nitrogen and fluorine. So a single bond. Okay, and one pair of electrons is shared between this nitrogen and fluorine. So a single bond. Similarly, one pair of electrons is shared between this nitrogen and fluorine. So one single bond between them. Alright, rest we have 2 electrons here for nitrogen. Okay, and here we have 6 electrons for this fluorine, 6 electrons for this fluorine, and 6 electrons for this fluorine. So you see, this is the Lewis representation for NF3. Okay, I hope it is clear to you. Thank you.